Hi, I'm Jason Huang. I'm Planning and Development Manager as part of the Campus Planning and Development Department for the University of the Witwatersrand. As part of our energy efficiency program, we identified kind of the heavy demand areas in terms of energy consumption, and one of the key areas is around hot water systems in our residences. The university currently has residences that cater for over 6,000 students, and as you can imagine, the energy demand related to hot water is quite significant. We are one of the few fortunate universities that actually have access to pipe gas. And having access to gas energy and supply directly to our campuses has made gas technologies a very viable system.
I'm Wally from Black Dot Energy, and I'm the design engineer that has done the design for these cogen systems for Wits. Wits had enormous cost from gas burners and heating that hot water and ensuring service delivery. What has happened now is Wits has strategically decided to reuse and reapply that gas and rather use Egoli Gas in generating baseload electricity using our generators. But the beauty of this is that by doing the heat exchanges and utilizing the heat exchange technology, all the heat from the engine block as well as all the heat from the exhaust now gives us an enormous capacity of waste heat. So in baseload, for about every 1 kilowatt hour of electrical energy, there's 1.6 kilowatt hours of thermal energy that now becomes available for free. So the benefits are just stacked on each other.
We've implemented our second and our third cogeneration system for our residences, which now caters for over, I'd say, over 2,500 students thus far.
The Bernardo Hall boiler room, which is part of the Bernardo Hall residence, and this boiler room is in actual fact 30 years old already. So we have this incredible 30,000 liters of hot water infrastructure to supply these students with ablution water. In fact, the consumption out of this Bernardo Hall plant room is in excess of about 70 to 80,000 liters a day. And the retaining of that heat is again a brand new groundbreaking technology, a first of its kind 40,000 liter low pressure storage tank with a high temperature resistant liner, and that tank is heated in excess of 80 degrees Celsius. The benefit, it's not a high pressure vessel, there's no rust and corrosion, and for all practical purpose, for very low maintenance, can last with excess of 20 to 30 years. I always say there's one green, and that's dollar green, unfortunately. This project was under an amount of 10 million, which sounds like quite a high capex investment. However, the saving on just this specific plant over the next 20 years for Wits is 190 million. The IRR return on this project is in excess of 34%. The additional benefit that we have is the existing hot water plants that obviously had older and aged gas burners in place. Those were earmarked to be replaced anyway. By having this additional heat available, all those older gas burners can now only become standby redundant energy generation systems, because we've basically taken the hot water system completely off grid. So that's an additional capex saving for Wits, not having to replace those gas burners. So that literally becomes just like a standby generation capacity should there possibly be done some maintenance on the generators or whatever is required. So those are all additional benefits in these financial solutions. The maintenance cost that we're looking at the system and overall is the plumbing and reticulation, which is very low. It's like a yearly of just checking strainers and filters. The generator system comes with a full SLA service level agreement maintenance program in place. And then the tank, as I've mentioned, with the low pressure storage, requires very little maintenance in terms of just checking and servicing pumps and reticulation. So from a maintenance perspective, there's again one of those amazing benefits of reducing the running cost of this entire project and making it so much more financially competitive. So in the design of this hot water plant, we had a base load generation of solar, roughly about 30 to 40% capacity, but then the gas burners giving us that primary base load generation of heat for service delivery for these students. In this cogeneration application, similar to what we had with Bernard Hall, that gas usage is now earmarked for power generation with our generator. The difference in their carbon footprint from COJ electricity to gas generated electricity is 30% only of that gas footprint they've had. One of the benefits of this system is also the reduced risk in terms of safety. So natural gas is lighter than air, so the risk that you have of safety is almost zero in this type of environment. If there is any leak, which is virtually impossible because our gas line or gas train as we call it, all those safety measures are built in, and hence why we have an entire network of gas infrastructure lines in Johannesburg, because it's such a safe technology. The percentage of downtime that we have in COJ electricity supply versus the downtime that we occasionally have from Egoli is marginal. The main reason for that is where electricity needs storage in terms of batteries, the gas network and the entire volume and high pressure gas that's available in the network itself gives us an enormous redundancy of backup gas. The Egoli Gas, Wits University, GA Solutions and Black Dot Energy relationship has really been key in changing the total energy environment in South Africa when it comes to backup energy as well as self-generation of energy. Our projects in what we've done in demonstrating the capacity of what cogeneration can do to the South African energy scope has also had international recognition. We have had the HVAC industry front page covers on the successes we've had. We have had the architectural industry recognizing the groundbreaking work that's been done. What we have been able to do with this project is find a perfect balance of getting the best and highest quality in terms of generation sets, and there the relationship of GA Solutions with Mayfield and Perkins as international partners that supply them the generation sets, as well as local partners that do the plumbing, the electrical panel design, our storage tanks. So the local content of this project is almost in excess of 80%. So we have the skill development, we have the local supplier industry being geared up and ready to roll this out en masse, but also have the support and backup from our international partners.
We did a lot of homework before we invested in these systems, and there was quite extensive modeling and quality review in terms of technology, also, but also the finances that went into these projects. So we did our homework up front, and we identified these as the best opportunity, because we have quite a diverse portfolio. There's various opportunities ranging from solar to whatever else there is on a typical property portfolio, and we had to prioritize our limited resources and allocate accordingly. So, and this was quite high up on the list for us. So this is it's a very worthwhile opportunity, and the systems are currently functioning. They are proving and running according to the expectations. So we're very satisfied with them, and that's why we're continuing with the deployment of gas technologies.
Wits is now able to generate electrical power cheaper than COJ's electricity tariff. Secondly, they can now save on the diesel backup generator infrastructure required, because by doing self-generation on site and reducing that City of Joburg base load, they save enormous amounts of money by having the capex infrastructure reduced, as well as the costs of running those diesel generators whenever there's power outages. Thirdly, service delivery is key, and not just only for the universities, any type of service delivery when it comes to hot water, especially with the COVID environment that we are faced with currently, that hygiene and being able to shower and wash is critical.